Okay, so we've solved some functions or some equations involving just exponential functions. Now we're going to solve some equations involving logarithmic functions. So for this one we have 2 log x equals 5. Now it doesn't have a specific base on it, so that means that it's understood to be log base 10. So remember that, that's important. So now we have 2 log base 10 of x, or of x equals 5. We need to get the log by itself before we can undo it. So we are going to divide both sides by a 2. That's going to give us log base 10 of x equals 5 over 2. So now what we're going to do is exponentiate both sides. That means we're making each side the exponent of 10. 10 is our base, so we want to undo log base 10 by putting a 10 here and a 10 here. That means that log base 10 of x is our exponent, and 5 over 2 is our exponent on the other side. So now on this side, on the left side, the log and the 10 undo each other. They're gone. And we have just an x. On the other side, we have 10 to the 5 over 2. Now we could simplify that if we chose to. We could make that, we could go ahead and do the powers and whatnot, but we don't have to. That's going to be 100, or the square root of 100,000, but we'll just leave it that way. So this is our answer. Okay? All right. Next. ln of the square root of x plus 2 equals the ln of x. So this one is a little bit easier because both sides have a natural log function. So that means that whatever's inside the natural log function has to be equal. So we have the square root of x plus 2 equals x. And now this looks just like a problem that we solved back in chapter 1. We're going to square both sides. And that's going to give us x plus 2 equals x squared. And then we're going to move everything over. 0 equals x squared minus x minus 2. This is factorable, so 0 equals, this is going to be x minus 2 and x plus 1. Okay, so that is x equals 2 and x equals negative 1. But we have to be really, really careful. We have to look at our original function. Our original function has ln of the square root of x plus 2 and ln of x. Now if I plug in 2 for x, then that's fine. I'm going to get the ln of x equals 2. I'm going to get the ln of the square root of 4 equals the ln of 2. That's okay. But if I plug in negative 1, I'm going to get x equals negative, if x equals negative 1, I'm going to get the square root of ln of the square root of 2 minus 1 equals ln of negative 1. And I can't take ln of negative 1. There's no, I cannot raise e to any power such that I'll get a negative 1. So this answer does not work. We have to cross out the negative value for our answer. Only x equals 2 is going to work. Okay, so that's an example of a problem with an extraneous solution. Okay. The last example is one where we are using laws of logarithms to solve an equation. So we have log base 10 of x minus log base 10 of x minus 3 equals 1. So that's why it's important that we need to review those logarithm rules. If we are subtracting two logs, then we can combine them using division. Log of x over x minus 3 equals 1. Okay? Now we're ready to undo the logarithm. And because our base is 10, we're going to exponentiate both sides with a 10. All right, so we have 10 to the log of x over x minus 3 equals 10 to the first. Okay, so now these are gone. And we have x over x minus 3 equals 10 to the first, which is just 10.
Dominic Jenkins, please report to the meeting.
Okay, so now we need to solve for x. To do that, we're going to multiply both sides by the denominator, which is x minus 3. We're going to get x equals 10x minus 30. We're going to subtract 10x on both sides. That gives us negative 9x equals negative 30. And then we're going to divide both sides by a negative 9. X equals 30 over 9, not 10, which is the same as 10 over 3. That's our answer. Okay? If we look back at the original, 10 over 3 is positive, so we're taking the log of a positive number. Even when we subtract 3, we'll still be able to get a positive number. So it works, which is good because it's our only answer. All right, so that's using logarithms, or solving equations involving logarithmic functions. There are a bunch of applications that we're going to talk about, and we will do those in the next video.